Alright, so 2.2 is called the distributive property. Part 1 is just about using the distributive property, and you probably already know what's going on with the distributive property. This is likely not a new thing that you've never learned before, quite the contrary. So finding the pattern, if you have 5 times this sum of 2 plus 6, you end up, you could potentially rewrite it as 10 plus 30. Here, instead of doing that subtraction to do 3 times this difference, you could potentially rewrite it as 24 minus 12. And then over here, finding the pattern, it's the distributive property. It means that if you have a number or a value, whether it's a variable or a number that, a constant, if it's being multiplied to a quantity in parentheses, like a sum or a difference, it means you can distribute that multiplication. So it's like A times B, and then the plus, and then A times C. The A is getting multiplied to both of those things. Just like down here, the B and the C that are being subtracted, this A is being multiplied to that quantity. Oh, there you go. Some current events as my mouse hits the. Oh, now it doesn't want to do it. So that's the distributive property. Again, it shouldn't be new to you, and so using the distributive property to simplify each expression. Okay. What could I say about this? Let's say you wanted to do this in your head without a calculator. You'd basically when people do something like this in their head, they're probably using the distributive property. Instead of doing 13 times 103 straight up, they go, well, I could do 13 times 100 and then 13 times 3 and then add those together. 13 times 100 is 1300. 13 times 3 is 39, which a lot of people can do that in their head. So this is like 1339, I do believe. 24 times 98. What was probably the idea here? To do 24 times 90 plus 8? Which I'm gonna go ahead and say this right here, right now. This is probably what it from the textbook, how this is supposed to be rewritten. But now doing this in your head, like I mentioned, the biggest application that I can think of right now is, so now you can do this in your head. 24 times 90, you might be able to do it in your head, and I might be able to do it in my head, but I don't know. Not so easy. Like 8 times 24, it's almost like just to do the 24 times 90, I'd almost want to do like its own breakup of distributive property, to do like 90 times 20 and then 90 times 4 and then add those together. Same thing doing 8 times 24. It's almost like I'd want to do its own distributive property breakdown of 8 times 20 and then 8 times 4 and add those together. But so maybe not the best example, especially if you're talking about just breaking it up so you could maybe just do it in your head. Like 15 times 40, like 4 times 15 is 60. So 40 times 15 would be 600, I do believe. And then 3 times 15 would be 45. So doing this in my head, well, writing it down a little bit to help. Oh, what the heck am I doing? 645. Let me just check the old calculator. Yeah. So look, we might have got a little bit off script here. Because I started talking about, well, oh my God, yeah. So because you know about the distributive property, potentially you could do problems like these in your head. But please, if you can't do something in your head, it's probably just best to grab a calculator if one's handy. But I think really this was just like an exercise in, applying your knowledge of what the distributive property is all about. So part 2 is just about simplifying. So like these back here, would you have to use the distributive property to evaluate that? Like, no, you wouldn't need to rewrite this as 10 plus 30 because we just got done last chapter talking about order of operations. So if you can do the 2 plus 6, then that might be what you do. So you just make that into an 8, then you do 5 times that. If you can do what's in parentheses, then, do it if you want. 8 minus 4 is 4. Then do 3 minus that. And then just like over here, you could do that because it's just 4 plus 9, then multiply by 2. You don't need to rewrite it with the distributive property. But these, look, if you said, I'm going to do the order of operations, I'm going to do what's in the parentheses, then I'm going to, no, because you literally can't do 5x plus 3. They are not like terms. Over here in this next example, not to get ahead of ourselves, but you can't do 3b minus 2. Those don't simplify. So all you can really do is distribute 2 times 5x and then 2 times 3. So what's 2 times 5x? Oh, geez. That caught me a little off guard. Writing it all out. Okay, well, here we go. What is, let me take 2. What is 2 times 5x? It's 10x. And then 2 times 3 is 6. And guess what? You're done because these don't add together. They're not like terms. This one has an x. This one does not. Next example, we're going to have to distribute. Okay? So I probably did it again, didn't I? 1/3 times 3b, and then minus what? We also have to do 1/3 times 2, or technically negative 2, right? And what is 1/3 times 3b? Oh, wow. Okay, yeah, really dragging this out. So remember to multiply fractions. You could say that's not just 3, it's 3 over 1. And then when you multiply those together, you get 3 over 3. But of course, that's just 1. So it's technically 1b, but you just write b. And then 2, same thing, multiplying these together, you could say, well, that's 2 over 1, and then numerator times numerator, denominator times denominator, multiplying across. Some say that gets you 2/3, or I guess technically negative 2/3. And yeah, there we go. Any other examples? Distributing a negative. Okay, yeah, look. If we have a negative out in front of a bubble, like this is a sum, or it could have been a difference, we're going to distribute that negative, basically treating it like -1, a negative outside parentheses. You can pretty much treat as a -1 times, okay? So I don't know what's behind these boxes in here by heart, like I can't remember. Well, yeah, that's what I just said that. So when we do -1, remember, times 6x, that becomes -6x. And then when we do like basically -1 times +4, it becomes -4. Or now it says -6x minus 4. Okay? Oh, I thought, okay. I was expecting on the last page maybe there to be a stop sign. Oh no, looks like there is more. In an algebraic expression, so in an expression, just an expression, not necessarily an equation, it doesn't have to be anyway. A term is a number, a variable, or the product, or a number and one or more variables, okay? So in this expression, that is a term. This is a term. Technically, it's negative. -5xy is a term. +3y is a term. And -12 is a term. Okay? So a term, like you could go back to the definition, but in an expression, the terms are basically separated by the plus signs and the minus signs. So that's a term, that's a term, that's a term, and that's a term. There's 4 terms here. A constant is a term that has no variables. So when you just have like the number 12, we can call it a constant because there's no variable that can vary. So this is constantly 12. So it's just a number. We could also call a constant. This appeared in the crossword we did last chapter. Let's write it down here officially. A coefficient is a numerical factor of a term, which, in other words, the number that's out in front of the variable or variables. So the 6, the -5, technically it's a -5, -5, not just 5, 3 or +3. Those are the coefficients. And then I already think I mentioned this in this video, but if they have the exact same variable factors, if 2 terms have the exact same variable situation going on, we call them like terms. So like these 2 things, they're not like terms. This has an x, this does not. So they don't have the same variable situation going on. Again, that's the final answer because they're not like terms, okay? So that does it for 2.2, the distributive property. Thank you for following along.